Hi, and welcome to the 6th video on Intermediate Python. So in this video I'm going to talk about comprehensions. And I think many of you have previously heard about list comprehensions, or maybe also dictionary comprehensions. So in Python there are 4 types of comprehensions. This is list comprehension, dictionary comprehension, set comprehension, and generator comprehension. So in this video I'm going to talk about all of them, essentially just making sure that you know everything you need to know about comprehensions. I'll also compare comprehensions with using map and filter functions in Python, and finally we'll look at when to use comprehensions and when not to use them. So this will be a pretty straightforward topic. I think comprehensions are super useful. It's a very neat Python specific syntax, and I hope you'll enjoy using them as well. So enough talking, let's head into the code. So here I am in an almost empty Jupyter notebook. I have some pre-written stuff here and we'll simply just move along and work through the notebook. So first of all, what are comprehensions? So comprehensions are what I and many others call syntactic sugar, which just means a very quick syntactic way of writing something that expands to something bigger to quickly generate lists, dictionary sets, and generators in Python. So here I have some setup. I have a nums list and I also have a names list. And let's now say that I want to square all the numbers here in the nums list. I could do this very manually. So I could make something like squared nums, just make it to an empty list. For each of these numbers, I could take my squared nums list here, use the append method, the squared number, and print it out. And here you can see I get a name error simply just because I forgot to run this cell. Let's run this. And let's run this, and here you can see the squared numbers. So doing things manually works fine, but there is like 3 lines of code to do one thing, and that can be improved with list comprehensions. So the comprehension syntax is, so let's first just make squared nums again. So here we'll use this comprehension syntax, and the way to do this is to use the list brackets, and inside here, first of all, specify the expression I want. So this is each number squared, and then select where I'm taking them from for each number in nums. So here you can see that it's kind of opposite. Here you first have the expression and then you say where you get it from. Here you first start to loop and then you do something. And I think this is an underappreciated thing about list comprehension, is that you start with what you're supposed to be doing and then you expand on the details. So the point here is to get the squared numbers and then you do it for each number in the list of numbers, right? On the other hand, if you're reading the code from top to bottom, it could be that you're not really understanding what's going on before you get to this point. I mean, the code is helping by giving this variable name squared nums, but still you really get to the point of it rather far down like here. But while you're doing list comprehensions, you get to the point at once and then you expand on where you get things from. And for me, this is a lot easier to read. And also, of course, the major advantage is that it's so much quicker to do than this thing here. So this is a list comprehension, the syntax, and you can use this syntax for all of the comprehensions. You simply have to change out something very minor. So here I can again make squared nums, but this time I want to make this into a set. So of course I could do the set constructor and then paste this in. This definitely works, but it's a bit cumbersome again. So what I can do instead is to actually just create set syntax here on both sides like this. This also gives me squared nums. So here I can maybe print it out after running it. Now you can see that I have a set, and of course you can also see that I don't have 2 copies of this 25 number because sets doesn't allow for repeated values. So that's a set comprehension, only changing these square brackets to curly brackets. And then we have a dictionary comprehension. So let's do something completely different. So we can do initial scores, maybe in a video game. Here we can specify name : 0, for instance, for name in names. And if I print this out, here we can see that we have Eirik 0, Stine 0, Bob 0, and Alice 0. So I've taken each name for name in names and put it as a key. Then I have a colon, and then I have the value is 0 for all of them. You can see that dictionary comprehensions and set comprehensions, they're kind of alike. They both use these curly brackets, right? The difference is, of course, that when you have dictionary comprehensions, you specify both a key and a value separated by a colon. And finally, we also have generator comprehensions. I briefly showed you this on the video on generators, but I can just show you again. So here we can, for instance, have people capitalized. We can call a variable. So hopefully this will give some intuition about what I'm going to do. Here we can do usual parentheses and do name dot capitalize for name in names. And if I now print this thing out, you can see that I just get a generator object. So recall from the video on generators that this only produces the values when I iterate over it, so it doesn't pre-calculate them. And comparing this also looks very similar to a list comprehension or a set comprehension. So look at this. For list comprehension, we have square brackets. Set comprehension, we have curly brackets. And for generator comprehensions, we have parentheses. And I think this is also a second kind of underemphasized point, is that when you start to do comprehensions, it's so easy to change a list to a generator if you need to. However, if you're in this thing here, if you really need to change this to a generator, then you need to make a generating function and use the yield keyword. There is a lot more work to transform this code into a generator, but transforming this code here, so a list comprehension, into a generator is just changing these square brackets here to just usual round parentheses. So these are the four: list, set, dictionary, and generator. When you talk about lists, sets, and dictionaries, there's usually one other data type that one talks about, and that's tuples. So what about tuples? There is unfortunately no comprehension syntax for tuples in Python, so if you want a tuple, you simply have to do it the kind of cumbersome way of using the tuple constructor. So I can still do squared nums and do tuple. This is a tuple constructor. So inside here, I can pass a list, or I can pass a generating expression. Like this. And you can see that it is in fact a tuple. So for a tuple, you have to do this kind of thing here if you want to do a comprehension syntax. Then I also want to mention that you can do some basic filtering. So far with the comprehensions, I've only really selected things and then done some expression. But you can also filter so that you don't select all of them. So let me just show you some basic filtering. So here I can make a variable called cool people. And here we have name.capitalize for name in names. This will just select all of the people, giving them a capitalized name. But here we can say some if condition. And this can be if anything. So we can, for instance, do if the first letter of the name capitalized is either an E or an S. And here we have an attribute error. So it's a string object has no attribute capitalized. It's capitalize without a D. And now it works. So here we have cool people, and this is Eirik and Stina. So this condition here selects away the two other names. If I remove this, just so you can see, here I get 4 names. So I'll just go back to the restricted one. And here you can see that you can do filtering. And really, you can play around with this as much as you want. Here you have an if condition, and you can specify basically anything you want that makes sense. So before moving on to talking about when to use versus when to not use comprehensions, let's just make a quick comparison with the map, filter, and lambda functions. So you can use the map or filter function together with a lambda function as a kind of alternative to list comprehension. Some people say that this looks less Pythonic. Let's take a look. So we can make r squared nums. So this is the map function. And the map function takes in 2 arguments. In the second argument, it's an iterator. So here we can take in nums. And in the first argument, it takes in a function. So we can make an anonymous function with a lambda expression. So here we can say lambda sends num to num squared. And this works. Here we get a map object, and this is essentially also a generator. If you iterate through this, you'll get all the squared numbers as before. Some people say that this looks less Pythonic. I'm not sure I really like this description because that's super vague, but for me at least, you do need to use here a function that takes in another function. So people who like functional programming think this is super nice. And I also like functional programming, but for me, this is kind of needlessly complicated for something so simple. If I have to compose functions just to square numbers, that to me makes it so that this is something that is less appealing. And even less appealingly, if I didn't want the generating expression, I had to have a list. Then as far as I know, what you have to do is just pass on the list constructor around this. And now we have a function passed into another function, passed into a list constructor. So again, kind of another function. This is way too nested just to create a list of squared numbers. And you can also use the filter function. So let's take the even numbers. So here we can have filter and then have a lambda function sending the number to the number divisible by 2 is equal to 0 and nums. So in the filter function, you need a function here that takes every element in the list and gives out the true or false value. So the values that it will have true are the ones that are even because they are divisible by 2, and those numbers will be filtered out by the filter function. It looks less clean, especially if you only need a list. Again, I showed you this previously, but I can show it again. So here you get a list. This to me looks overly complicated, honestly, and I personally don't like it that much. It's not wrong to do this in any way. I know some people who like this, but I really prefer list comprehensions to this. So if I try to do the same thing here, then I simply pick every number, and then I give my condition. So num divided by 2 should be 0. And I think this is more readable. And for me, it's also a bit more extendable because say now that I want to pick out the even numbers, but I also want to square them, then I can just do this, right? But here it's not so clear what I'm supposed to do then, because I can't simply start squaring here because the lambda function in the first argument is supposed to give out true or false values. So then I need to first filter, return a new list, and then do a map function here where I have a new lambda function sending number to number squared, and this is my thing in the second argument. And you can see here that, I mean, this looks pretty awful just to do something rather simple. So I'll simply cut it back like this and have it as I originally had it. Personally, even though I like comprehensions better than filter or map, it's again nothing wrong with using them, and even in some cases it's good to use them. And especially also if you want to understand functional programming, then using map and filter functions are super instructive, I think. But if I'm being honest, I mostly use comprehensions. So finally, now I've been talking about comprehensions and how awesome they are for some time, so I should talk about when not to use them. So here I've already written the code just because it takes some time, so I'll walk you through it. So here I said that comprehensions are meant to make the code more comprehensible. That's the reason for the name, right? So if they don't, then don't use them. It can look awful, as I point out, because if it gets too large, it becomes very unreadable. So here I have cool people. It's name.capitalize for name in names. If the first letter is an E or an S, and then I have to scroll, and the last letter in lowercase is K. And here it takes quite a bit of effort for me to actually read this. And I wrote it, right? So if I wrote it, I should be able to read it super easily. If someone else wrote something like this, it probably takes me 10 to 20 seconds to understand what they're actually doing. I think this looks pretty awful. Here you just get Eirik back. You can format it better. This is something that's slightly helping. So here you can see that. So here I have cool people, and inside a comprehension, you can really do a lot of formatting. So here you can have name.capitalize for name in names, if this condition and this condition. This helps. This makes it better, I think. And you can more or less do anything. I can do it like this. Doesn't look better, but I can do it. So you have some flexibility with how you want to format it. This helps definitely, but I think in this case, I would honestly just do it in the manual way. So here I think this is the most readable. So yes, so I say maybe it's really more readable to just write it out, quote unquote. So I have my cool people list for each of the names. I check 2 conditions, and if it satisfies, I append the capitalized version. I think actually for me, this is easier to read, and it's also easier to check each line if there is a mistake. If you really have it all coupled up in one enormous line like this, it's easy to let a mistake slip by. So the golden rule of using versus not using comprehensions is that you should use them when the code becomes more comprehensible or more readable, and if they don't, you should not use them. And honestly, I use them quite a lot because they're super useful. They're great if you want to do something quick with a list or a set or a dictionary or a generator. And I think this is really all there is to say about comprehensions. I hope you found this instructive. In the next video, I'm of course continuing this series on intermediate Python. I really like making this series because I learn something new for each video, even if it's just a really tiny thing. So if you like the content we're providing here, then like and subscribe, and I'll see you again in the next video.